Okay, so I'm going to talk a little bit about our notes, the idea we've been talking about, which is cell transport. And I'm going to kind of give you a real brief definition of this, maybe give you a diagram or something so you can see it in a more basic way. And then I want you to, I'm going to show you what I mean by a Venn diagram. And then I want you to construct a Venn diagram based on something we've learned. Okay, so cell transport is the flow of particles from high to low. Okay, so like if you have oxygen, so we got O2 over here, O2 over here. We got how many? So we got 4 O2s on this side, and we can just call this like a membrane here. This would be one side of the cell, this would be another cell. They're right next to each other. And over here, we have 2 O2s. Okay? And what's going to happen, because they go from high to low, there's going to be some of these particles, because there's 4 to 2, one's going to come over, maybe even 2 come over, right? But now we have 4 on this side, so then O2 is going to go back. But eventually we're going to get to the point where there's 3 on one, 3 O2 on one side, and 3 O2 on the other. Okay, that's an example of cell transport. Move this up a little bit. So that's an idea, and this is this little thing we got here. This is just the cell membrane. We're kind of 2 cells, 1 cell on this side, 1 cell on this side, and this is just how these things happen. It can be oxygen, it can be water, it can be lots of stuff like that. So, and we have 2 different types that we usually talk about. One is diffusion. I'll bring this down in just a minute. Okay, diffusion. And then another one, there's 2 types of that, and another one is osmosis. Okay. And with diffusion, there's passive transport, and then there's facilitated. Okay, and then with osmosis, this is really a type of diffusion, and this is water only, H2O only. That's what it's talking about. I'll talk about that in just a minute. I'm going to show you this Venn diagram. So here again, diffusion is passive and facilitated. Both of these diffusion, no energy. That's because they're just doing this. They're doing what's natural. You have a whole bunch of something on one side, very little on the other. So then where there's a whole bunch, it goes to the side where there's very little. Sometimes it comes back because maybe it overloads it and has to come back a little bit. But in the end, they'll even out and they'll reach something called equilibrium. Okay, and that's tied in, if you remember back, all living things do certain things, and one of them is homeostasis, a stable condition. And that's what's going on here in the cell. Okay, and then the way this cell transport works, 2 main types, and we're going to talk about one other type later after we're done with this, is diffusion and osmosis. And diffusion is passive, just particles, but it can also be facilitated. We have these channels. Let's see if I can show you a real quick picture that will be done. So let's say we have a membrane here, and here we have like a little channel. And we have, let's say, a molecule, we'll just make them a shape now. We have 3 over here and 1 over there, okay? And they want to go from high to low, and they want to do that. But these little openings in the cell, and maybe they're charged improperly because this is a charged, this membrane is charged, they can't get through. They're too big to get through the openings, and they're charged or something. So instead they use this channel that's made of proteins, and then this will help bring 1 across. And then we'd have 2 over here and 2 over here. And just like we were talking about with this one, okay, sometimes they'll send a whole bunch over, then there's more on this side, and they'll go back and forth. But eventually they reach equilibrium. Okay, and that's because all living things want to accomplish homeostasis if they can. Okay, and that's the same thing here. So this is facilitated, right? And then we can talk about active. We're not going to talk about this time. But so we have high to low. This is the concentration gradient they call, which is kind of like a difference. Like if you're on a hill Like this is the top, this is the bottom, right? This is a whole bunch, this is very little. So they always go from the concentration gradient from high to low. Now an active transport is going to go from low to high, but we're not talking about this today. Okay, so what I want you to do for your homework is I want you to make a Venn diagram. So you're going to make two circles, and they're going to overlap. Hopefully my circles look good. Yeah, they're okay. These don't have to be perfect. This is a Venn diagram. It's horrible. I'm fixing this. Try again here. It's not very good. Try it again. Make a decent circle. Let them overlap a lot. Okay, that's okay. That's a little better. One over here looks like an egg, but we'll live with it. Okay, so this is a Venn diagram. And it's where you compare things, right? How things are the same is in the middle, and how they're different is on the outside. Okay, I usually like to list, though, different things, comparison when they're contrasting. I list them the same, but you don't have to. Okay, so if we were going to do this, let's say we did cats and dogs. So we have a cat over here, and we have a dog over here, right? So, and then how are they the same? They're both animals. They both have 4 legs. Both have fur. You could go on and on. These are the things they share, right? They're the same. And then the things that are different. So dogs are canines. Cats are felines. Okay? And then we could say cats purr, dogs bark. What else? Dogs are loyal. Cats are aloof. I don't know if that's really true, but I'm just trying to think of things here. So things that are different, and I like to compare them. So the things that are the same, I put in the same order, right? And you can think of a lot of ways they're the same and different. What I want you to do is I want you to make a Venn diagram, and I want you to compare a couple things. So I want you to compare, ignore the announcement here, diffusion versus osmosis. You can do that one. Okay, that's one you could choose. Maybe you want to do A, diffusion versus osmosis. You could also choose to do passive transport to facilitated. You could also do, let me see, you could do, that's probably the two that can't think of too many more, but you could be creative. So if you can come up with something that's very similar, right, you can compare them as well. And you're just going to make a circle. We're just going to do this. Take a piece of blank paper, draw one circle, and we're going to draw another circle, and you're going to put diffusion, say this is the two you choose, and this is osmosis, and then you put what do they share, how are they different, right? Okay, just want to add one more thing actually, when I'm done. 8 minutes. Okay, so the thing to remember about osmosis, I haven't talked about this. This is H2O only. So you kind of, the H2O thing is a little different, just slightly different. So if I was going to draw a little cell here, and we have H2O, 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 right? H2O, like this, right? So they can come across, right? And then we have 3 over here and 2, and they come back then, right? And the thing to remember, though, is that we're talking about cells here. So within this cell is not just water, there's other things. So you have like sodium, NaCl, or maybe you have some C6H12O6 in here as well. Okay, some of these particles are so big that they can't move. Okay, so you may not be able to have diffusion of some of these particles back and forth because they're too big. And so the only thing that can move is water. And how you kind of see this happening is you see the cell get really big. So if a whole bunch of water has to come in here, Because maybe if it's not in another cell, maybe if it's in a beaker, you take a beaker and you take an egg and you put it in water, right? And the concentration of water inside is 25%, and the concentration of the water is 100%. The water is going to want to go in here and try to make it 100%. It will never be able to do that because there's a solvent in here that can't get out and be in here. So eventually what it does, if you leave it in there long enough, it'll burst. Okay? That sometimes takes a long time. And that's why I'll add this. That's why salmon, right? So salmon live in the ocean, and they swim out when they're old enough, and they become adults, and they come back to reproduce. Well, when they come back in the ocean, they come to the mouth of the river where the water's mixed and there's a lot of fresh water. They sit there for a while because they don't want to be swimming upstream and all of a sudden have to take on all this fresh water and burst cells and die. So what they do is they come in and they sit in the mouth of the river and they get their cells pretty normal, and then they start swimming upstream. Okay, but I figured I'd add that since we're in Alaska and we like salmon. So that's what I want you to do is I want you to create a Venn diagram. If I can find one on diffusion or osmosis, or passive transport, active transport, maybe even facilitated diffusion and osmosis, whatever it is. Create this, have it in class on Tuesday, and we will discuss. Okay, talk to you later.